Okay, let's have a quick read. It goes, in the past, the time for Jeff's journey to work had a mean of 45.7 minutes and a standard deviation, so that is sigma already, 5.6. This year he is trying a new route in order to test whether the new route has reduced, I'm going to underline that one, his journey time. Jeff finds a mean time of his random sample of 30, so n is 30, this is a random sample. Using the new route, he carries out a hypothesis test at, and I'm just going to put 2.5% is that. I'm just writing key things on there that I'm going to use later to set it up, okay, as I read through it. Now, Jeff assumes that the new route, the journey has a normal distribution with a standard deviation of 5.6. So he's comparing it same to that, what his other route was. So we're happy with that. So state appropriate null hypothesis and alternative hypothesis for the test. Now, new route, and he said that it's going to reduce the time. Okay, so he's telling you to put it as, we're going to test it for whether it's reducing it. So first of all, setting off, our null hypothesis is the mean time is 45.7. and we are checking our alternative hypothesis that's going to be reduced. It's going to be less than 45.7. That's how we're going to run. So you got 2 marks there. Okay. Then I'm going to put here, determine a rejection region for the test. Right. So we know that it's a one-tailed test. At significance level 0.025, 2.5%. So we've got that. So I'm going to put, this is starting my B section. So one to significance level 0.05. And we also know that his new route, let's call it X. To those normal distribution, we'll keep the mean as it is, 45.7, and it's told you that the standard deviation is the same. I'm putting 5.6. Now when you set it up, just put a squared there just in case, because they normally have it as a mean and variance, so I'm just putting it there. You won't need it, but just so that you know that you don't square root it again. Okay, so we got that, and we need to know now. Before I start here, sorry, one thing I needed to do here, which I didn't do, he took a random sample of 30. I did highlight that. So like I said, it's important because I nearly forgot it when I realized there's 30. So because he's done 30 journeys, don't forget to divide that by 30, because you need to go back and do that, because it is from a sample of what he's testing against his usual route. Okay. So I'm just double checking. I've included that, I've included that, I've included that sample, and I've included that happy dates. That's why it's important getting a highlighter or get your red pen and write these things on the paper, which you might need to use up and you don't miss them out. Now, given that's the case, he now says we need to find a region. So it goes here, determine the rejection region. Now before I start, I'm just going to, again, I like drawing anyway, but it's nice to draw and see how things are. So we know that we want to find a rejection region here. So this is our critical value. Which we're going to find out, given that is going to be 45.7. And this region here, we're going to find out is going to be 0.025. And this is to reject. HO, null hypothesis, this is acceptance. I think you might get some marks just to show that, see what's going on, so you know what's going on. Reject H0. I'm going to put it. Okay, so now we got that, happy days. And then we just run through it, see what we got to get that. I'm just trying to see what's the best way to do this. Right, if we had put probability critical value, let's call that x1. So we want to find when is x less than x1, which will give us a probability of 0.025, or less than, you can put it. So we want to find that value, which is going to give you a probability less than or equal to that. Just what we did earlier on in one of the questions. So if you go on your calculator, can you type all that in for me, please? And we do it together, so making sure we've got, so distribution 7, inverse normal distribution. Now the area is going to be 0.025. Now I'm just going to put square root, well actually I'm going to put 5.6 divided by root 30. You should get 1.0224, and then the mean is 45.7. Now this tells me that xi from this is from the calculator, is going to equal 43.696.1 blah blah blah. So any value, so I'm just doing just freezing in figures. So a rejection region, say rejection region is when x1 is less than 43.7 minutes. Is it minutes? Yeah. So that's your rejection region. Any value that is 43.7 or less, you would reject that hypothesis, and the mean would have been reduced by that, and that is it.